இறைவா நன்றி. எல்லையில்லாதானே, எங்கேயும் எப்போதும் என் குலம் காப்பவனே, நெஞ்சம் துணிய துணையாய் வருவாய், நேர்மறை உணர்வுகள் பெருகிடச் செய்வாய், உடலில் உறுதியை பெரிதாய் தருவாய், உனை உணரும் அறிவை என்னுள்ளருள்வாய், சுற்றம் அனைத்தும் காப்பவனே, செய் தொழிலில் ஏற்றம் தருபவனே, எடுத்த செயலில் வெற்றிடு, என்னால் கொடு, கருவாக்கி உருவாக்கி எனையாண்டு காத்தருளும் இறைவா நன்றி. வல்லமை தந்து நீ மலர்ச்சி கொடு, என் அகத்திலும் புறத்திலும் மலர்ச்சி கொடு, வல்லமை தந்து நீ வளர்ச்சி கொடு, என் அகத்திலும் புறத்திலும் மலர்ச்சி கொடு.
Very good morning to one and all present here. I am very happy to welcome today's chief guest, Mrs. N. Anita, Assistant Professor, Department of Mathematics, KCT College. And I like to welcome our Director, Sir, Dr. DFS Christopher, Administrative Director, School of Computer Studies for the session. Welcome, sir. And I warm welcome to our Dr. Yamini Ma'am, Director, Academic. And I also welcome DPT Coordinator of Computer Science Department, Dr. B. Jayanti, HOD CS. And I am very happy to welcome HODs of School of Computer Studies. And I like to welcome Dr. Dhanabalan sir, Department of Microbiology, Ratnavil Subramaniam College of Arts and Science, and HODs of other departments. And it's my pleasure to welcome all the faculty members of our department. And special thanks to our principal sir and vice principal sir. Thank you, sir. Welcome, ma'am. Anita, ma'am.
Yeah, good morning, ma'am. It's my pleasure to take a part in today's webinar on statistical analysis using R. I would like to extend my sincere thanks to RVS College of Arts and Science Management, Principal sir, and Vice
Anita, ma'am, your voice is not audible, ma'am.
Am I audible now, ma'am? Just a minute, ma'am.
RP? Padmapriya ma'am.
Ma'am, சொல்லுங்க.
Chief guest introduction.
Ma'am, கொடுத்துருங்க.
Ma'am, now am I audible, ma'am? Ma'am, now am I audible?
Ma'am, audible, ma'am. 1 minute, ma'am. Suganya, ma'am, can you proceed, ma'am?
Okay, ma'am. Okay. Is it audible?
Yes, ma'am.
Yes, yes.
Very good morning to one and all. I am very happy to introduce today's guest, Dr. N. Anita, Department of Science and Humanities, KCT College.
Yes, ma'am.
She has completed her PhD in VIT Chennai. She is having teaching experience of 8 years in teaching and as well in research. She has qualified Tamil Nadu state level eligibility test conducted by Government of Tamil Nadu. She has received the Best Young Faculty Award from KCT. Her areas of research are fuzzy optimization, optimization techniques, and linear algebra, and etc. She has published various research papers in reputed national as well international journals and as well in national and international conferences also. She has organized various international FDPs, workshop, and various activities for the welfare of students and as well for the faculty members. And we are very glad to welcome and have you for this session, madam. Welcome you once again. Thank you.
Thank you, ma'am. Thank you for your introduction, ma'am. Ma'am, am I audible, ma'am?
Ma'am, it only little bit, ma'am. It's not that much audible.
Is it very feeble, ma'am? Is it very feeble, ma'am?
Ma'am, your voice is
Yes,
clear,
ma'am.
ma'am,
Yes,
but
ma'am.
its voice is very low.
I think.
Just a minute. Ma'am, is it fine, ma'am? Padmapriya, ma'am, is it
Okay,
fine now,
ma'am.
ma'am?
Okay, ma'am. Okay.
Yeah. It's my pleasure to take a part in today's webinar on a statistical analysis using R. I would like to extend my sincere thanks to RVS College of Arts and Science Management, a principal sir and vice principal sir, and also the various head of the department and the head of the Department of Computer Science and Computer Applications, Dr. Jayanti ma'am and Dr. Padmapriya ma'am, and warm greetings to all the professors. Ma'am, shall I start the session, ma'am?
Yes, ma'am.
Ma'am, before that, I would like to ask one thing, whether faculties are going to try side by side or shall I proceed, ma'am?
Ma'am, they will try side by side, ma'am. We have to give some time, at least 10 minutes for them to follow, ma'am.
Yeah, ma'am. The thing is that my request is, if they are ready with the RStudio, they can open the RStudio, ma'am,
Okay,
for the practice.
Okay, ma'am. Okay.
Yeah. You kindly make a request, ma'am.
Okay, ma'am.
Because based on that, I will move according to that.
Okay. Okay, ma'am.
Yeah. So, respected professors, welcome you all for today's session. So, in today's session, we are going to discuss about the testing of hypothesis, statistical significance testing. And the overview of today's session is, first, I'm going to talk a little about the testing of hypothesis. Then I will move to the t-test, some parametric test and non-parametric test. So in parametric, I'm going to touch the t-test, f-test, and ANOVA. And in non-parametric, I'm going to touch the chi-square test. So as all we know that the hypothesis testing is the process to test the significance regarding the parameters of the population on the basis of the sample. It has been established by J. Neiman and Pearson. And the objective of the hypothesis testing is to help the researcher in obtaining a conclusion regarding the population by examining the sample from that population. One simple example I will say, suppose now we are in a pandemic situation. Suppose we are having a fever more than 3 days or 4 days means, usually after fever is sustaining more than 3 days means, usually we will go to the doctor, right? Then doctor will say that have to take the blood test.
So we are giving the blood only the few ml are required for the as a sample only we are giving for the testing. So just to correlate with the testing of hypothesis, in our body we are having so much of blood. So that much of blood is known as the population. And for testing, we are giving a particular sample, whatever required in the laboratory. So we are giving the sample to the laboratory and they will analyze the factors. Then they will give the report. Then with the report, whatever the report we are getting, then we are giving the report to our whole body, right? So to the whole population. So that is the testing of hypothesis. So we are having a population of data, big data. Just we will take a part of the data and we will analyze the parameters of the sample. Then we will conclude the sample result to the population. So this is the simple way to understand the testing of hypothesis. Then based on the sample size, we are going with a small sample or a larger sample. That will vary. So the basic thing is, this is the thing. So the sample characteristics are used to estimate the population. So population is nothing but the group of individuals under the study is called the population, and the subsets which we are taken from the population is known as the sample. Then the number of individuals in the sample is called as the sample size, and the parameter means the numerical measure pertaining to a characteristic of population, and the same as well as a numerical measure pertaining to the sample is known as the statistic. So hypothesis is a statement about one or more populations, and the statement about the parameters of the population about which the statement is made. So this is called the hypothesis. For example, as I said, that suppose as a physician, they are hypothesizing the drug D is effective in 90% of the cases of which it is used. So hypothesis is nothing but the assumption. And they can, based on the previous year result, we can assume that the average pass percentage of grade 12 for this year is 98. Yes, ma'am. Ma'am, anything happened? Okay, ma'am. Okay.
No.
Okay. So through the hypothesis testing, the researcher or the investigator can determine whether the assumed statement are compatible with the available data. So hypothesis will be of two types. One is research hypothesis and another one is the statistical hypothesis. So research hypothesis means we will have the tentative solution with us. So it is the supposition that motivates the research. In research, the researcher determined whether or not their supposition can be supported through scientific investigation. So this research hypothesis will directly will lead to the statistical hypothesis. So we know the statistical hypothesis strategies. The statement about the population which we want to verify on the basis of information available from the sample is the statistical hypothesis, and it can be of two types. One is the null hypothesis and another thing is the alternative hypothesis. So always the null hypothesis will state that there will be no difference between the sample statistics and the population parameter, or any difference found is due to fluctuations in sampling. And the alternative hypothesis is just the complementary to the null hypothesis. So various steps are involved in testing the hypothesis. So as we all know that for testing anything, we need the data. So after the data, the data will follow the normal distribution because it is the big data, it is the population. So from the population, we will collect the sample. So for that sample, with the help of the sample statistic and the population parameter, we have to define the statistical hypothesis, means the null hypothesis and alternative hypothesis. Then we have to define the significance level. Then we have to test the test statistic. Then decision rule we know. So based on the test statistic and the decision rule, finally we will take the statistical decision. So these are the steps involved in testing any, any test, any type of testing hypothesis. So these are the rules to state the statistical hypothesis. For example, our population means our big data average means mean. So population mean is 30, means 30 is given, right? So population mean is not 30 is given. So first we have to define the null hypothesis and alternative hypothesis. So always null hypothesis will state that there will be no difference. So the mean will be equal to 30 we have to take. And the given is the population mean is not 30. So that will be our alternative hypothesis. So as well, if the population mean is greater than 30, then our null hypothesis is same and alternative will be the original. Mu is greater than 30. So mu is nothing but it is the parameter of the population. And the population mean is less than 30, then the statistical hypothesis will be have to be defined like this. H naught will be mu equal to 30 and the alternative hypothesis is the given thing, means the mu is less than 30. Then the main thing is that we should know the type of errors. So in testing of hypothesis, surely error will occur. So the test statistic we are assuming no, so everything will be based on the null hypothesis. So if null hypothesis is true and we are accepting the decision, then it will be a correct decision. Suppose null hypothesis is true, but we are taking the decision as we are rejecting it, then automatically error will occur. That error is known as type 1 error. So type 1 error is our alpha, and alpha is also known as the level of significance. Next, the null hypothesis is false, but we are accepting the decision. Then also error will occur. That kind of error is known as type 2 error. So the probability of making that error is usually represented by beta. And the last one is null hypothesis is false and we are rejecting. We are taking the decision as the rejection. Then it will be the correct decision. So the complement to the type 1 error and type 2 error is, type 1 error complement is 1 minus alpha. So the 1 minus alpha is nothing but the confidence level. And the complement to the type 2 error, beta is there, no? So the type 2 error complement is 1 minus beta. It is known as the power of test. So the type 1 error will be minimizing by decreasing the alpha value, and by minimizing beta, we have to reduce the type 2 error by increasing the difference of alternative hypothesis, or increasing the sample size, or increasing the alpha. Then I'll come to the critical region. So the region corresponding to the test statistic in the sample space, which leads to the rejection of the null hypothesis. And the complementary region is known as the region of the acceptance. So now only we discussed about the level of significance, because level of significance playing a vital role in testing of hypothesis. So type 1 error only we are concentrating. So probability alpha is known as the level of significance. So 1 minus beta is known as the power of the test. Then this picture clearly will explain the critical region and the critical value. So the shaded region on both sides is known as the rejection region, or the level of significance. And the unshaded region is called as the non-rejection region. So just a minute. So here, this is the normal distribution curve. We know that. So here our rejection region is on both sides. So the point is there, no, the point which dividing the rejection region and the non-rejection region is known as the critical value. So manually, we are calculating the problems manually means we will take the critical value from the statistical table. So here itself, I would like to explain the one tail and two tail also. So the shaded region is here, no? So here the both side it is shaded, so it is alpha by 2, and here also it is alpha by 2 because level of significance is alpha, we know. So it is distributed on both sides, so it is alpha by 2 and it is alpha by 2. So if the rejection region is on both sides, then it is said to be a two-tailed test. Suppose only one side the rejection region is existing, then it will be called as the one-tailed test. Either if it is in left side, it is called left tail test. If it is fully lying in right side, it is called the right tail test. And the non-rejection region is the unshaded region. So from here to here, we can mark from here to here. That means the critical value to this critical value. So this is nothing but this is the confidence interval. Just the complement to alpha, it's 1 minus alpha. No? So this is the confidence interval or fiducial limits. Like that also we will call it. Next, we'll see the few things about the test statistic. So test statistic is the statistic computed from the data sample, and it will have many possible values that the test statistic can assume. And test statistic value depends on the sample, and the test statistic is the decision maker in testing of hypothesis. So based on that, we will take the decision that either we can accept the null hypothesis or reject the null hypothesis. So generally, we will frame the test statistic by using this formula. Means the difference between the relevant statistic and the hypothesized parameter upon standard error of the relevant statistic. Most probably, we will follow the test statistic, but it is not applicable to all. So now we'll come to the statistical decision. So it is the decision of accepting or rejecting the null hypothesis. So we reject the null hypothesis if the computed value of the test statistic is fall in the rejection region. And we will not reject the null hypothesis if the computed value fall in the non-rejection region. So finally, we will reject the null hypothesis means we have to accept the alternative hypothesis. If we are accepting the null hypothesis, then defaultly we have to reject the alternative hypothesis. So this is the flow chart of testing of hypothesis. So data, then tester. Then we have to define the statistical hypothesis, means null and alternative. Then we have to take the level of significance. Then we have to apply the appropriate test statistic based on the sample size. Then we have to calculate the test statistic. Then based on the critical value, we'll take the decision. So if you are not rejecting the H naught, means the null hypothesis is true. If you are rejecting the null hypothesis, then the alternative hypothesis is true. So these are the few things about the testing of hypothesis. Now we'll move on to the parametric test. So parametric test means it's nothing but we are having some certain ideas about the data set. Means the data set will follow the normal distribution like that. So in parametric there are so many things, but today we are going to discuss about t-test, f-test and ANOVA test. If time permits, we can discuss the largest sample test, means that z-test also. Then after that, we will discuss the non-parametric test, means the chi-square test, the goodness of fitness and the testing, the checking the independence of attributes also. We will discuss it later. So now, first, we'll see the applications of the student t-test. So based on the sample size, we have to decide the test. So if the sample size is less than or equal to 30, then we are calling the sample as small sample. So in today's session, we are going to discuss the three things with the help of the student t-test. The first thing is we are going to apply the t-test to test the hypothesis about population mean, which means we are going to take only one sample from the population and we are going to test the hypothesis. Second thing, we are going to apply the t-test to test the hypothesis about two means. So from two different population, we are going to take the two sample, we are going to check the two sample, and we are going to give the conclusion for the two population. And last, we are going to apply the paired t-test to test the hypothesis about the means of two dependent sample. So in the second thing, the samples will be independent, but the third thing, the samples will be dependent, because with the same set of sample only we are going to check the another thing. So these are the three things we are going to check. Ma'am? Ma'am, whether professors are going to do it by the side, ma'am? Because I would like to explain a few things about the RStudio, then I will move to the problems, ma'am.
Okay, ma'am.
Ma'am, kindly confirm that, ma'am.
Okay, ma'am.
Yeah, because yes, ma'am. Because few may know about the RStudio, few may not know the RStudio.
Yes, ma'am. Few may know, few may not know, ma'am.
Yes, ma'am. Yes, ma'am. Just I will give a brief note about the R for a few minutes. Then I will start it, ma'am.
Okay, okay, ma'am.
Yes. So we know that R programming is a language and software environment for statistical analysis and also for the data interpretation. And R is created by Ross Ihak and Robert Gentleman. So the both inventor name were started with R. That's why it is called as R programming. And it is well developed, simple and effective programming language, which includes conditionals, loops, user defined recursive functions, as well as input and output facilities. And the main thing is that it is having a large number of built-in packages, functions, and operators, and it is an open source also. So we can able to install in n number of packages, and it is free and with the free of cost. So, but today we are going to discuss with the RStudio. So if you are opening the RStudio, then your screen will be like this. So there are four windows will be there. The first thing is the source window or the editor window. And below that, we are having the console window. So if we are giving the programs here, then we are executing, the outputs will be displayed in the console window. And in the right top, we are having the one small window, no? So this is the history window, and also environment also will be there. And below that, we are having another window. We can, with the help of that window, we can able to see our files, and we can able to see our plots. If you are plotting that, we are doing any plots, the output will be here. Then the packages, whatever we want to install, we can use it here. And the thing is that help also we can get from the last window. So these are the simple thing, because somebody knows and somebody don't knows. So if you are opening the R, editor, command and console, and the instruction packages will be there. With the help of the editor, we are going to do the problems today. And the thing is that R is case sensitive. And the various types of OR objects are vectors, list, matrices, arrays, factors, and data frames. So first here we have to create the object. So in R, we have to create the object, or we have to concatenate the object with the help of C with the open parenthesis. So we have to create everything with the help of the C of. C of means we are creating the object. For example, I would like to create a simple vector 1, 2, 3, 4 means I can't to give simply 1, 2, 3, 4 in RStudio. I have to create it, right? So C of within the parenthesis you have to give. So for numeric data, no need to include the quotations. If you are giving any kind of strings, then you have to define with the quotation. So we know that logical, integers, numeric, complex, and characters, everything we know that. So if we want to generate some sequence, means in RStudio, we can give the built-in code as sequence. So SEQ will give you the sequence. If 1 to 10 you are giving means it will take the common difference, default difference it will take, and it will display the output. And you want some common difference means you have to give sequence from 1 to 15 by equal to 2. If you are giving, then it will show you the common difference with the 2, and it will give the output. As well as for taking the simple operations I have included here. You want some square root of 2 means you can directly give as sqrt of 2. Suppose you are defining the variable, then also you can able to find the square root. So these are the two ways to getting the square roots. And addition and multiplication are common thing like C. So for multiplication, here you have to use the asterisk symbol. Then the thing is that help is there. So with the help of using the help, you can learn by yourself, and you're having any doubts, you can learn by there. And next thing, I'm coming to the most important thing, creating the matrices using vectors. Suppose simply I have taken for creating the 3 cross 3 matrix. So in our studio, how to create the simple matrix means a matrix of data equals sequence value I am taking, random value I am taking. So from 1 to 9 I am taking. Then I am defining the number of rows and number of columns. So I planned to create 3 cross 3. So number of rows 3 and number of columns 3 I have to define. So if I am defining this, then if I am executing it, then my output will be like this. But here you can look into that the numbers or filled column wise. So 1 starts from column, and then it fills by next column, then it fills by next column. Suppose you want to fill the data in row wise means you have to give by row equal to true. So true is a logical value, so no need to define the strings here. So matrix of data, n rows, n columns you define, then by row equal to true you are giving means then the data will be filled row wise. Suppose we want to add some more column or some more row to the existing matrix means how to do, just we will see that. So for that here I am taking the different thing. I am creating 2 vectors u and v. So I have to create the object. So from 9 to 12, I'm creating the first vector. Then 13 to 16, I'm creating the second vector. So like see here also we have to print the variables. Here you are defining the variable as you know, so you have to print it. So like that we have to print it. So then only we will get the outputs. So here I got the output. So this is here we are having 2 rows and 4 columns. Suppose I want to create a 4 cross 2 matrix, then what I have to do? Now, as usual, we have to take matrix, and already here we combined the vectors now. So here 4 cross 2 matrix I created by using the another variable called w, and I created u and v. Here I have combined the u and v. So now I got 8 elements. So w is our new vector now. Now we are going to frame a 4 cross 2 matrix with the help of the new vector. For that, I am defining one variable name as mat. Then matrix of data is w, and we planned for 4 cross 2. So number of row is 4 and number of column is 2. Then you have to print it. So now we got the output as 4 rows and 2 columns. Then we need the row sums means then we can give row sums of this mat. So mat is our final variable name. We want the row sums means we can give row sums of the mat. Then column sums of the mat we are giving, then it will give you the 2 column sum. Ma'am, am I audible, ma'am?
Yes, ma'am.
Yes. Yes, ma'am, because just I got it out.
Okay, ma'am.
My
Audible,
PDF
ma'am.
is visible, no, ma'am?
Yes, ma'am, it's visible.
Yeah, no, visible, no, ma'am.
Visible, ma'am,
Yes,
visible.
ma'am. Yes, ma'am. Yes, thank you, ma'am. Thank you, ma'am. So next I will show how to add one more column or row. But before that, just look into that. We want the row sums for the taken matrix. Then we have to give row sums of mat, then column sums of mat. And we wanted the dimension means we can check the dimension, dimension of mat. So it will give 4 cross 2. So that is our dimension. Now we want to add or rows or columns to the existing matrix means we have to give C bind or R bind. So here I'm going to add a column vector. So I have used C bind. C bind means it will add the new vectors with column wise. If we want to add the row means we have to give the row bind. So already the existing matrix is there, no? There only we have to add. So MAT is our matrix. So in the same matrix only we have to add. We should not change the variable name here. So matrix C bind of already existing matrix is there, no? So this is the existing matrix. In that matrix, comma, you have to give the 17 is to 20 is the decided value for the column. For the third column, we have to give 17 to 20. Now we have to print means then we will get the output like this. So like this, you can use R bind also. Instead of C bind, if you are using R bind, then the new row will be added, but there you have to take 3 elements because it is already here, no? So we have to take the 2 elements we have to take. So 17:18 if you are taking, then you will get the new row in with the existing matrix. So these are the few things about the matrix formations and adding rows and adding columns. And next thing is there, but later we will discuss that. Now quickly I'm moving to the RStudio. So if we are opening the RStudio, you will get the page like this. Then if you want to proceed means you can open the R script. So it will show here the new R script will be there. Suppose if you are unable to see the fourth window, if you are seeing only 3 windows means no problem. We can focus on the hidden window. For that, you have to go to view. You have to give move focus to source or move focus to console, move focus to terminal, move focus to help. So these are the 4 things. If something is hidden, you just give the focus to that, then you will get the 4 windows. Hope now I can start my testing of hypothesis. So already we discussed that. First thing, we are going to test the hypothesis about the population mean. So as we are a mathematician, we know the testing of hypothesis about population mean theory. The theory is we are going to select only one sample from the population. Then we will apply all the testing. Then we will take the decision. Then that decision will finally goes to the population. This is the testing of hypothesis for single mean. So here we already, this also we know that 2-tailed and 1-tailed. If the critical level of significance or rejection region is distributed on both sides, then it is known to be a 2-tailed test. If it is only one side, then it will be known as the 1-tailed test. So first, for testing the hypothesis, we have to we have to create the objects. So the samples we are taking, that sample data we have to create. So this is the general thing. X means it is not a built-in, just we are assigning the variable name. So X equal to, we are creating the object with the help of the sample data. Then these are the inbuilt function. So T dot test, within the parenthesis, you enter your defined variable X, then alternative hypothesis here you have to define. So if it is two-sided, then we have to give it is two dot sided. If it is one sided, we have to give based on that less or greater. Then we have to define our null hypothesis here. So mu equal to only will be our null hypothesis. So mu means the population parameter. It will be given in the problem. So based on that, we will take the mu value. So this is the R code for testing the hypothesis about population mean. If suppose it is for one tail test, as usual, we have to create the objects, then we have to give t dot test of the defined variable, then alternative hypothesis you have to define, and null hypothesis you have to define. Suppose nothing is given means the confidence interval means the level of significance, it will defaultly take as alpha. Alpha is 5%. So confidence interval means 95%. Okay, so alpha is 1% means then the confidence interval will be 99%. So we want to include the confidence interval also means additionally here we can include that. Next, to test the hypothesis about two means. So two samples we are going to take from two different population. So A and B we have to define, then T dot test of A comma B, then alternative hypothesis you have to define based on the problem. Then in checking the two means in T test, we know that the variance will be unknown. So under the assumption of variance or equal only, we are proceeding the T test. We know that. So that one we have to mention here. So variance is equal to true. We have to be mentioned here. Then only this RStudio will give you the t-test output for two means. Suppose if you are giving variance equal is false, then it will not give you the two sample t-test. It will give some other test. Then last thing is paired t-test. So paired t-test is a dependent test because with this existing sample only, we are going to check the next thing. So paired equal to true, we have to mention here. Remaining thing, everything is same. So now let us see the simple problems. 11 articles produced by a factory were chosen at random and their weights were to be found to be in kilograms are given here respectively. In the light of the above data, can we assume that the mean weight of the articles produced by the factory is 66 kilograms? Excuse me, ma'am, Batmapriya ma'am. Ma'am, my speed is okay, ma'am, or shall I go little bit slow or a little bit fast, or is it okay,
no,
ma'am?
It's okay, ma'am. Okay.
Okay, ma'am. Okay. So the factory produces the n number of articles. So that n number of article mean is given. So it is mu value. So mu is 66 is given. And from the n number of articles, we are selecting only 11 articles. So the sample size is less than 30 means then we have to proceed with the t-test that we all know. So 11 articles only we are taking. Okay, so here directly I gave it, but always we should remember that the procedure of testing of hypothesis, the first thing is we have to define the null hypothesis. So the null hypothesis means here mu will be equal to 66 kg is our null hypothesis. And alternative hypothesis is mu is not equal to 66 because from this question it is clear that it is two-sided, it is not a one-sided. And third thing is level of significance. In problem, level of significance is not discussed. So as a statistician and a mathematician, we know that a level of significance is not given, then we can assume that it can be 5% or 1%. But most probably we will consider the level of significance is 5%. Level of significance means the rejection region. The fourth thing is our test statistic. The fifth thing is our conclusion. So now here we are defining, we are creating the object in our R by using C of the given data. So we know the alternative hypothesis as two-sided here, and null hypothesis is mu H naught is mu equal to 66. Just we have to include here. So T dot test of X with alternative equal to 2 dots hidden. Why we are representing in parameter in quotation means because it is a string and mu equal to 66. So if you are entering this thing in your R Studio and if you are executing, then you will get the output. So if we are doing manual, we will take the decision with the test statistic as well as with the critical value. But here no need of that critical value and here probability value will be given. So based on the probability value and the level of significance, directly we can take the decision. So now I entered. So if we are, see here X, we have to select and we have to, you can able to see the run option here, right? So if you are clicking that, then it will execute and the output will be in your console window. And the shortcut for the execution is control together. If you are pressing control and enter, it will execute your program. So we can able to see here one sample t-test is given. So degrees of freedom, it is single sample. So degrees of freedom formula is n minus 1. So 11 article we have taken. So 11 minus 1 is 10. It is obtained here. And test statistic, we will apply the formula x bar minus mu by s by root sigma. Root sigma by n, we will apply the formula. But no need of the formulas here because it is inbuilt. So it calculated and the test statistic is 2.3. And also it has calculated the p-value also. We know how to calculate p-value. With the statistical table and with the level of significance, we will calculate the p-value, then we will compare it. But in R, we will get the p-value here. Now, let us see how to take the decision. So this is the output which we obtained from our studio. So if P in manual calculation, if our calculated value is less than the critical value, then we will accept the null hypothesis. Again, I'm repeating, if our computed value is less than the table, statistical table value, then we will accept the null hypothesis. But here it is controversy. If the p-value is less than the alpha value, then we will reject the null hypothesis. So in this problem, the p-value is 0.4425. It is obvious that alpha is 5%. So alpha is 0.05. So it is less. So we are rejecting the null hypothesis and we are concluding that mu is not equal to 66, which means we may conclude that the mean weight of the articles produced by the factory is not 66 kgs. So this is the computational exercise actually I have taken for faculty practice. Ma'am, will they practice now or will they practice later, ma'am?
Ma'am, they'll practice later, ma'am. We'll get your PPT, ma'am, then we'll practice later, ma'am.
Okay, ma'am, fine, ma'am. Okay.
Okay, ma'am.
Next, we'll move to the next test. So next is testing the two means. So 2 sample t-test here. So 6 subjects were given a drug. One is for treatment group and an additional 6 subjects a placebo means the control group. We are taking 6 groups from a treatment group and control group. Then the reaction time to a stimulus was measured in MS. So the placebo group data is given and the treatment group data is given. So what we have to analyze means, can we conclude that the reaction time of the placebo group is less than that of the treatment group? So from the question itself, it is very clear that it is a one-tailed test because placebo group means the first group. First group is the control group. Is less than that of the treatment group. So it is the two-tailed test. So first, for testing any kind of hypothesis, we have to go with the procedure: null hypothesis, alternative hypothesis. In the last case, we have taken only one sample, but here we are taking two different samples from two different population, which have to be follow the normal distribution. So the null hypothesis is always is equal. So mu1 equal to mu2 means the reaction time of the two groups are equal, and the alternative hypothesis will be decided based on the question. So it is given as placebo group is less than that of the treatment group. So mu1 is less than mu2. Now level of significance is not discussed in the problem. So alpha equal to 5% we will consider. Now T dot test. So we have to create the objects in the R studio. So control is the decided variable. I have decided like that. You can decide any variable, any variable name. So control equal to, you have to create the object with the help of the given sample data. Then create the another thing, treat equal to create the object. Then we are going to compare the two means. No, so T dot test of control along with the treat, and alternative hypothesis we have to give here. So mu1 is less than mu2, so we have to give alternative is less. So within a quotation you have to give less, and we all know that in testing the two means with the help of t-test, always the hidden consideration is the variances will be equal, and the variance is also unknown. So for that we are giving variance dot var dot equal to true we are giving. So we have to give true, otherwise we won't get two sample t-test. I will show you the proof. So if we are giving it, we will get the output like this. So test statistic value is minus 3.4456 we got. So degrees of freedom for two sample, we know that N1 plus N2 minus 2. So here six data we have taken. So 6 plus 6 will give you 12. So the 12 minus 2 is 10. So that is the degrees of freedom here. Just I am saying to compare the existing thing with the output from the R code, and P value also given. So we will take the decision based on the P value and the alpha value. And here one more thing, the confidence interval also given. So minus infinity to minus 0.608274 is our confidence interval. So here P value was 0.003136. So it is less than the alpha value. So alpha value is 0.05. So we know that if P value is less than alpha, then we will reject the null hypothesis. So here also we are rejecting the null hypothesis. So we are concluding that the alternative hypothesis is true. Means the reaction time of placebo group is less than that of the treatment group. Now I would like to show you what will happen if we are giving variance dot equal as false. So in the same R script we can give. So thing is that whatever required we can select the particular thing, then we can execute it. So now I'm giving variance dot equal to true. So now I got like this. So one more thing I forget to say, if we want to clear the console history means you can just click the brush, it will go. Now I'm executing. So it is two sample t-test. Suppose I'm giving variance equal is false, I won't get the two sample t-test. I will get the output for some other test. So Welch two sample t-test we will get, because it is not our default thing. It is something different. So this is the difference for between variance equal is true and variance equal is false. And one computational exercise I have given. Then now I will come to the paired t-test. A study before going to the paired t-test, I just want to give one simple example to understand the difference between the paired t-test and the difference between two means of the two samples, because in both tests we are going to take two samples, right? For example, in our day-to-day life example, I will consider, suppose if we want to measure our sugar level, what we will do? We will go to the doctor in either a stomach, in empty stomach in early morning, or in noon also we can go. So in empty stomach, we will give the blood sample for sugar test. Then after taking some food, again we will give the blood sample for taking the sugar test. So here the person is same person. Okay, the person is same person. But the thing is that before food we are giving one sample, after food we are giving another sample. So the person is same, no? So that sample will be dependent, right? So here we are taking two different samples, but it is dependent. So if it is dependent, then only we have to go to the paired t-test. Like that, we have to understand the concept. Otherwise, we might might commit the mistakes. So here, a study, now I'll come to the given thing. A study was performed to test whether cars get better mileage on a premium gas than on regular gas. Each of 10 cars was first filled with either regular or premium gas, decided by a coin toss, and the mileage for that tank was recorded. The mileage was recorded again for the same cars using the other kind of gasoline, and the relevant mileages are given here. So the car is same car, but the gasoline which we are using to check the mileages are different. That is the given thing. Just correlate with the existing example with this problem, then you can able to clearly understand the difference between the last thing and this thing. Now, here it is given as a paired. Suppose if it is not given, we have to decide. Suppose we are doing the research problems, then we have to think when to apply that one and when to apply this one. So use a paired t-test to determine whether cars get significantly better mileage with premium gas. So the alternative hypothesis is clearly given, and it is two-sided, because we have to check the cars get significantly better mileage with premium gas. So regular and premium we are having, we have to check whether it is getting better mileage. Means the alternative hypothesis will be two-sided. So everything is important, because based on that only we will get the decision. So the null hypothesis is two sample we are taking, but the two samples dependent here. So H0 is mu1 equals mu2, and alternative hypothesis is mu1 less than mu2, because premium is better we gave, no? So regular we are taking as first thing, and premium we are getting second, means then the premium is better, means mu2 will be greatest. So H1 is mu1 less than mu2, and level of significance is not discussed. So defaultly it will take alpha equal to 5%. If we want to give also, we can give. Nothing wrong with that. Now we have to create the objects. So for regular gas, I have created the object, and the premium gas, I have created the object. The thing is paired equal to true, we have to give. So T dot test of the defined variable REG and premium or PREM, and alternative is here it is less, no? So we have to give within a quote, we have to give less, and paired equal to true we have to give. So if you are giving this, you will get the output like this. So test statistic value, degrees of freedom value, and p value we will get, and the confidence interval, 95% confidence interval also we will get. So the conclusion will be based on the p value and the alpha value. So it is clear that the p value is 0.0007749. So the alpha value is 0.05. If the p value is less than the level of significance, we will reject the null hypothesis. So here we are rejecting the null hypothesis and we are accepting the alternative hypothesis, means we are concluding that there may be a significant difference between the mileage with regular gas and premium gas, or the the car gets significant difference with better mileage with premium gas. So this is the conclusion, and like this we can take the decision. So one simple computational exercise is given in before training and after training. As a teachers, we can conduct before coaching and after coaching. We are measuring the test marks. So that kind of example is given. Later you can test. Now I'm moving to the next test. I mean F test. So applications of F test. So F test is used to compare the variances. So T test we have used to compare the means, single mean and two means, and the paired test also we have compared the two means. In F test we are going to compare the variances. So for comparing the variances we have to take two samples. So two samples from normal population we are going to take, and we are going to apply the F test to compare the variances. So the procedure for doing the experiment is given here. So for T test we have taken T dot test. So for variance F test we have to give VAR, variance dot test of two samples anyway we are going to check, we are going to take, because we are going to analyze that. So X comma Y and ratio equal to 1. Why to give the ratio equal to 1 means we know that in F test, in theoretically I'm talking, in F test we will consider the population variances will be equal. The first population variance and the second population variance will be equal. Then the with the estimate variance only we will frame the test statistic. So that's why here we are taking ratio equal to 1. So var dot test, or within the parenthesis you define your declared variable, and ratio equal to 1 you have to give, and alternative hypothesis you have to define, either two-sided or less, one-sided, less or greater. If we want, then already I said no, confidence level we want to give means we can give. So confidence level 95% means it is understood, you have to understood that alpha equal to 5%. So complement is confidence level. So CONF dot level will give you the confidence level. So this is the procedure for doing the experiment. Now we will see one simple example. Two samples of 6 and 7 items respectively have the following values for a variable. And one more thing, it is not necessary that we are taking two samples. No, it is not necessary that the length of the two sample need not to be equal. It's not necessary. They can be equal or that they can be unequal. So here in sample 1 we are having 6 data. In sample 2 we are having 7 data. So we have to check, do the sample variances differ significantly? So from the question it is clear the alternative hypothesis is two-sided, because we are going to check whether it is significant or not. We are not going to check which is best, which is worst, like that we are not going to check. So it is a two-sided test. So null hypothesis you define, alternative hypothesis we have to define, then level of significance is not given, so alpha is 5%. Now for test statistic, I'm coming to the R code. So created the objects for X and Y separately, then variance dot test of X comma Y and ratio equal to 1 we have to give, and alternative hypothesis is two-sided, no, so alternative equal to 2 dot sided. So you can give without the creating the object also, without COF also you can give, nothing wrong, but this also is the another way. And confidence level 95% we are giving, means alpha equal to 5%. So if we are executing it in our studio, your output will be like this. So test statistic value, see here 1.8323 is our test statistic value, and the degrees of freedom. So degrees of freedom is we obtained the degrees of freedom here. So now if you are executing, we will get the output like this. So this is our F value. So theoretically what we will do, we will compare the computed value with the critical value and we will take the decision. But here the degrees of freedom will differ because the theoretical formula is F equal to S1 squared by S2 squared. So which variance is highest, then we have to interchange the variance to the numerator, right? So for that sample, the degrees of freedom, then denominator, we have to define the degrees of freedom separately. So in first sample, we are having 7 things. So 7 minus 1 is 6. So number of degrees of freedom for the first is 6. And the degree of freedom for the second. Yes, ma'am.
Ma'am, voice konja break agudanga ma'am.
Sorry,
Voice
ma'am.
konja break agudanga ma'am.
Yeah, yes, ma'am. I'll check it, ma'am. 1 second, ma'am. Network connectivity good only, ma'am. Ma'am, now is it fine, ma'am?
Fine, ma'am. Fine.
Fine. Okay, thank you, ma'am. So in second sample, we are having 6 things. So 6 minus 1 is 5. So denominator degree of freedom is 5. So based on the degree of freedom, we'll calculate the critical value in manually. But here it's not necessary. So based on the p value and alpha value, we are going to take the decision. Now the p value is 0.523, but alpha is 0.05. So p value is greater than the alpha value, means we should not reject. We have to accept the null hypothesis. So we are accepting the null hypothesis means our decision is, we may conclude that there is no significant difference in the sample variances. So this is the computational exercise for your F test. Then in between I'm coming to the non-parametric test. Later again I will switch over to the parametric, means ANOVA later I will switch over. Now I'll go to the chi-square test. So the objective here is to apply chi-square test for goodness of it, and the second objective is to apply the chi-square test for independence of attributes. So first thing is chi-square test of goodness of fit. Excuse me, ma'am, am I audible? Because in between I am getting some noise.
Yes, ma'am. You are audible, ma'am.
Okay, ma'am, because some disturbance is coming. I don't know from somebody's or from mine. I don't know, ma'am. That's why just I cross. Yeah, now it's fine, ma'am.
Okay, ma'am.
Yeah, thank you, ma'am. So as we all know that parametric test means we can make certain assumptions about the data set, means the data are drawn from normal distribution or something else. But now we are going to discuss about the non-parametric. So non-parametric means we can't to make all certain assumptions. We can make a few assumptions only about the data set. So that is the difference between the parametric and non-parametric. So first thing we are going to check the goodness of fit. So in goodness of fit, why we are using means goodness of fit determines how well the theoretical distribution fits with the empirical distribution. So theoretical distribution means we know that there are so many, Poisson distribution, binomial distribution, uniform, normal distribution, so many things are there. Just we are checking whether how well the theoretical distribution fits with the empirical distribution. So that is the main aim of checking the goodness of fit for any kind of goodness of fit. But here we are using the chi-square as the tool. So the simple problem is depicted here. The following table gives the number of aircraft accidents that occur during the various days of a week. Find whether the accidents are uniformly distributed over the week. So the accidents are given, and the number of days we know that per a week we are having 7 days, and the number of accidents are given. One more thing is clearly mentioned in the problem. We have to check whether the accidents are uniformly distributed over the week. So we have to understand here the theoretical distribution is uniform distribution. Just we are going to check whether the theoretical fits with the empirical distribution. So null hypothesis. So here we are not going to check the mean, variance, everything. Just with the observed value, we are going to check the expected thing. That's all. So the null hypothesis will be the accidents are uniformly distributed. Alternative is accidents are not uniformly distributed over the week. Level of significance is as usual, nothing is given, then we will take 5%. Now we will come to the R code. So first we have to create the object with the given data. So the number of accidents only given here. So we are defining the data with the accident variable name. Now we have to define the p-value because we are given as uniform distribution. So we have to give the uniform expected values. So per week there are 7 days, right? So equally we have to distribute all the days, means it is 1/7. So for all the 7 days we are giving 1/7. So this is the expected thing. So p is not a built-in. Instead of p you can give some xy also, no problem. But in chi-square, in R, by using the chi-square dot test as the inbuilt function, we can check the chi-square. So A equal to chi-square dot test of accident, comma, enter the expected thing. So one expected frequency. So 1/7, 1/7, no. So just you include it here. Like see here, we have to print it. Suppose if you are not declaring A equal to, then fine. If you are declaring any variable for the code, then you have to print it. Then only we can able to execute the program. So this is the program. If I am executing, then we will get the output like this: chi-squared equal to 4.1667 and degrees of freedom value and p-value. So here the number of data is 7. So degree of freedom is n-1. So 7 minus 1 is 7. So by manually means we will use the formula to get the chi-square, right? Summation observed minus expected, like that we will use. But here everything is inbuilt. So here no need to include anything. So you can use as it is. Now we got the output is p-value equals 0.6541. And as usual, we are going to compare the p-value with the alpha value. So alpha is 0.05. So alpha is less comparing to p-value. So p-value is greater. If p-value is greater, then we have to accept the null hypothesis. So we are accepting the null hypothesis means what is the meaning? The accidents are uniformly distributed. Means the theoretical distribution here fits perfectly with the empirical distribution. So that is the conclusion. So for a computational exercise, I have taken one simple problem and gave it. You all can try it later. Then we'll go to the next thing. Chi-square.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, in the p-value we have taken 1/7, 1/7, no, ma'am.
No, that is not.
Computational exercise, 1/7.
That p is different. This is just a variable name. This is just
variable is p. So we have taken 1/7. It is expected, no, ma'am?
Yes, ma'am. It is expected because it is an uniform distribution, ma'am. So uniformly we are assigning 1/7 for all the number of accidents.
Okay, ma'am. Ma'am, can you tell what will be the p-value of the next one, ma'am? Computational exercise.
Here, ma'am.
Yes, ma'am.
Yeah, the following is the distribution of the hourly number of trucks arriving at company's warehouse. So trucks arriving R is given and frequency is given, and test whether the arrival of trucks is equally. So here also it is equal, no? So how many number of data? 1, 2, 4, 6, 8, 9, no ma'am. So 1
Yes,
by
ma'am.
9, 1 by 9 you have to give.
Okay,
So
okay.
expected will be 1 by 9, 1 by 9 for all the frequency.
Okay, ma'am. Okay.
Oh, okay, ma'am.
Okay, then.
Yes, ma'am. Next is testing the independence of attributes. So we are going to check whether is there any relation between the two attributes. So for that thing, we are using the chi-square as a tool for checking two attributes. So sorry, directly I went to the problem. Okay, no problem. So here a simple problem is given. A survey of 920 people that ask for their preference of one of three ice cream flavors. So chocolate, vanilla, strawberry gives the follows result. Using chi-square, determine whether or not there is an association between gender and preference of ice cream flavor. So here there are two attributes. The one attribute is gender and the another attribute is the flavor of the ice cream. So we have to check whether is there any relation between the ice cream flavor with the gender. That is the thing we have to analyze. So for this kind of thing, we can use the chi-square as a tool. So here men and women along with the three flavors of the ice creams are given. So manually what we will do, we will use the contingency table, or we will go with the test statistic, and we'll check the degrees of freedom. Then based on that we will check the critical value and we will give the conclusion. But here we have to fill the data as a data frame in R. Then we have to check the chi-square test. So men and women are there, no? So I am giving the data for men and women. So men equals, we should not include the total, just the three flavors along with the men and women we have to give here. So 100, 120, 60 you can give. Then for women 350, 290 you can give. Then ice cream, I define the variable name. It is our wish. Nothing is inbuilt here other than chi-square dot test. Everything is subject to change only. So now, just like that, we can't to check the chi-square test here. First, we want to form it as a data frame. Data frame means we know that we have to make it as a table. Okay. So as dot data dot frame of, here we have entered the data in row wise. So 100, 120 in row wise we have taken. So R bind I am giving. So R bind of men, comma, women you have to give. Then you close the parenthesis. Then you want to see the data frame means here you can print the ice cream. Otherwise directly result alone enough means directly we can go with the chi-square test. So chi-square test of the data frame we created now, that ice cream you have to give, and simulate p dot value equal to true we have to give, because it will simulate it. It will simulate it because inbuilt for 2000 replicates it is it is an inbuilt thing. So we are giving simulate p value equal to true. So if we are giving it, then our output will be like this. So we have created the data as a data frame. Then our result we got like this. So degree of freedom is not applicable is given. It is nothing but 2 cross 2, no. So we know the degree of freedom is 1. Row minus 1 into column minus 1. So 2 minus 1, 2 minus is 1. But here there is no need of degrees of freedom in taking the decision, because we are going to compare the p value with the alpha value. So here p value is less than the alpha value. So we are rejecting the null hypothesis. Just I would like to execute it. In R, just I would like to execute. So just I'm giving. So here I didn't print it. Now if I am printing, it means I can see the data frame clearly. Now this is the data frame. Suppose we are not printing. Then directly we can get the result. We can't see the data frame because we didn't print it here directly. We can get the final result alone. So this is the difference of printing the required variable. Everybody knows. Just for a reminder, I'm just suggesting here. Okay. So this is the chi-square test. And one computational exercise is given. Now again, I'm switch over to the parametric test. Means ANOVA, one-way classification. So we all know about the ANOVA. So few may not know about the ANOVA. ANOVA means the analysis of variance. So mean and variance are interrelated. So to check the variance that we are using the ANOVA, you can ask to check the variance we are having F test, then why should we go to the ANOVA? In F test, we can able to compare the variance of two samples. If we are having more than two samples, 2, 3, like that, if we are having more than two samples, means we want to compare more than two populations, then we can't use the F test. Then that's why we are moving to the ANOVA. So this is the thing why we are using the ANOVA. So in one-way ANOVA is a statistical technique that allows us to compare mean differences of one independent variable across two or more groups of one independent variable. So here dependent variable will be called as response, independent variable will be called as factor. If there are only two levels of independent variables, the results are analogs to student t-test also, because if the sample size is less than 30, then we can move with the t-test also. So the R code for checking the ANOVA is AOV of response tilde factor. So response is dependent, factor is independent, because we should be clear which is factor, which is response. Then only we can predict the research problem results. And data equal to data name, whatever data name we are taking, we have to give here. So this is the simple R code for ANOVA. But while doing mathematically, what we will do it for more than 10 to 15 minutes. But here it's not like that. We can consume our time. And before that, I would like to differentiate. For example, we can take our fertilizer land. So we want to get the cultivation, means there are so many factors. The cultivation depends on so many factors. So here cultivation is the response. Okay. So cultivation depends on the quality of soil and the amount of water and the quality of fertilizers. So like this, we are having n number of factors. One way means we are checking the cultivation with the quality of any one of the factor, like quality of soil. So based on the quality of soil, what is the cultivation? If we are assessing this, then it will come under one-way ANOVA. So cultivation is dependent. Cultivation depends on the quality of soil. Why we have to go to two-way ANOVA means, in the same example itself I am extending, we want cultivation, good cultivation. So I'm just taking soil quality and amount of water. So amount of water is one variable, soil quality is another variable. So two are independent because soil quality is not depends on the water level. So both will be different, means independent. So based on these two things, how the cultivation happened. So we are analyzing how many factors? Two factors, but the response is only one thing, that is cultivation. So like this, we are analyzing two factor, means we have to go to the two-way ANOVA. When we have to go to three-way ANOVA, we are adding one more factor. Now I am adding quality of fertilizer into it. So cultivation is based on quality of soil, water level, and the fertilizer quality. So 3-way ANOVA, it is latent square. What will happen if more than 3 factors? Then it will be a multi-level ANOVA. It will goes like this. So this is a simple way to understand when to use 1-way ANOVA and when to use the 2-way ANOVA. Now I will explain one simple thing. A drug company tested 3 formulations of a pain relief medicine for migraine headache sufferers. For the experiment, 27 volunteers were selected and 9 were randomly assigned to one of 3 drug formulations. The subjects were instructed to take the drug during their next migraine headache episode and to report their pain on a scale of 1 to 10, 10 being the maximum pain. So it is clear that the drug company have measured the migraine pain based on the episodes, and the pain of the persons or measure, I mean, they have rated it the scale between from 1 to 10. So 27 volunteers were taken, and drug A is randomly given to 9%, drug B is given to some other next 9%, drug C is given to some other next 9%. So we can easily understand that the drug A, drug B, drug C along with the pain are there, no? So these are the 3 samples. Okay. So more than 2 means then only we have to go with ANOVA, like that we discussed. So here it is 3, no? So if we are having more than 2 or more than 3, then we can go with the ANOVA and checking the variances. So here it is very clear which is the dependent, which is the independent. So randomly they have taken, no? So randomly pains have measured, and with the drug A, drug B, drug C, and here the pain is dependent on the drug. So drug is independent, pain is dependent. Okay. So here factor is drug, pain is response. So like that we have to first finalize, then now we'll see what is the R code for checking this data. So first we have to enter the data according to the drug wise. So for drug A entered first, drug B entered first, then drug C, because then only we have to get it in the order. So pain is the variable name which I have decided. Then we have to formulate it, no? So 4, 5, 4, first 9 values belongs to drug A. So we have to tell to the computer. So we have to give it. And there are 3 important principles also there for designing of experiments: replication, randomization, repetition, and local control. So we are giving the replication here. So A, 9 means the first 9 value belongs to the A drug. Next, replication of B, 9 means next 9 value will belong to the B drug. Similarly for the next one. Now we have to form it as a data frame. Then only we can able to do the result. So data is my data name. So data equal to data.frame of pain along with the drug. You just print the data to get the data frame. Now give the result. So we know that the R code is respond tilde factor. So result is AOV of within the parenthesis give. Here the response is pain, the factor is drug, comma data equal to the data name. Here data is our data name, right? So don't think that always data will be the data name. Here just I have taken data. So this is the data name. So we are repeating the data here. But summary only we want, no? So we have to print the summary, a summary of results. If you are giving this, then you will get the output like this. So the data frame you can able to see here. Then summary we gave. So this is the summary. So manually we will form the ANOVA table. 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 So manually we will for between the sample and the error, and we will find the degree of freedom, sum of square, mean sum of square, then F ratio, right? So everything it will give. And additionally, it will gives the probability value also. So the probability is 0.000256. So we will take the decision based upon the p-value and alpha value. So alpha value is 5%, no? So p is less than 5. So we are rejecting the null hypothesis. So like this, we can take the decision. This is the one-way ANOVA to check the one factor. Now I will come to the second thing, to perform the analysis of variance for a randomized block design. So randomized block design is nothing but is another name of two-way ANOVA. So here we are going to analyze two factor, no? So we'll make it into a blocks. That's why it is known as the randomized block design. So two-way ANOVA compares the means of populations that are classified in two ways, or the mean responses in two factor experiments. In the two-way ANOVA model, there are two factors, each with several levels. So this is the R code for a minimum number of data. This R code will be used to calculate the manual working problems. If the problem is just appropriately small, then we can apply this R code. If you want to analyze in large number of data, means if data is existing in Excel, or you want to check the inbuilt function, means no need to give everything. That is another short way in analyze the variance for two factors. Okay, first I will explain this thing. The following data represents the number of units of filled cookies produced per day turned out by different workers using 4 different types of machines. So machine type along with the worker is given. Okay. Anyway, worker and machine, whatever they are doing, finally it will reflect on the company's turned out. Okay. So the company, they are filling the cookies, no? So finally that will be the target. So here the response is the company's productivity. And the two factors are worker and machine. So which is dependent? The company's turned out or the mean productivity is dependent. Machine type and worker are independent. So we have to test whether the Feynman differ with respect to mean productivity, and test whether the mean productivity is same for 4 different machine types. So we have to check for both worker and machines. So for that, we have to give the input as the data to understand the computer to form the data frame. So null hypothesis we will define as there is no significant difference, and alternative hypothesis will be here. It is significant or not only we have to check. So it is not equal to. Then see here, A and F are the variable name. So A equal to, I'm first entering the machine data. So column wise I am entering. So 44, 46, 34, 43 like that. Column wise I have entered. Then I want to show the row wise also, because row wise we are having 5 workers. So 5 workers now. So I am giving the 5 workers within a double quotation. So F equal to C of W1, W2 are the strings. So we are representing with quotes. And K represents the rows, R represents the columns. So here K is the rows. So 5 rows and column is 4. So here column is 4. Now we have to generate the levels of the factors. Okay, because we have to generate it. So first we are generating the worker level. So worker equals GL means it will generate the level. So worker is row wise, no? So row wise we are taking. So row, comma, each and every row will be generate one time, and the loop will stop if it reaches the maximum length. So string length is here 5 into 4 is 20. So if it reaches the 20, then it will stop. Comma, the factor of this thing. W1, W2 we defined, for workers. So that thing you have to print the worker. Then formation we have to give. So formation it is column wise. So column comma row. Then we have to give K star R. Then mention. Then we have to give the ANOVA. So A is the dependent because the mean productivity is the data. So the company's turned out or mean productivity, it is the dependent. It depends on worker and machine. Then we have to give the summary. So whatever we are doing manually, just to correlate it, the same thing only here also we are following. What we will do in manually, first we will find the correction factor. Then we will analyze the sum of the total sum of the square. Then we will find R1, R2, R3 means the sum of the square between the blocks and between the rows and columns, then between the error. Then finally we will form it as a ANOVA table. So in ANOVA table we will take two ratios. One ratio will be with the mean sum of the square of column and error, and the second ratio will be with the sum of the with the help of the mean sum of square of rows along with the error. So we will get two ratios. That two ratios will be compared to the critical value and we will take the decision. So this is the thing we are doing manually. Same thing also are also doing. So see, looking to the ANOVA table, degree of freedom is given, residual means error. So residual degree of freedom is given, sum of the square means sum of the square, and F ratio is given, probability value is given. Now here the conclusion is, we have to give the conclusion for two factors. One is for worker and another is for machine. So for worker, p-value is 0.00485 and for machines the p-value is this one. So here both p-values are less than alpha. So we are rejecting both null hypothesis here. So we are concluding that the 5 men workers and 4 machines or differ, okay, because they are differing with respect to the mean productivity. So this is the example for two-way ANOVA with a simple problem. Now we'll see one problem with the big data or with the all the existing data. Just I will show it. So import the data set tooth growth and carry out a two-way analysis of tooth growth, which depends on supplement type and dose. So there are so many data are already available in our R. Just I will show you. Just for randomly, I have taken one thing to show you how to check the two-way analysis. If you are giving data sets, you can able to see so many of already existing data are available. So many are existing. So many things are there. Okay. So from this data, I have taken the tooth growth to check the two-way analysis. Okay. Just I'm showing there are already so many inbuilt data are available. So I have selected the tooth growth. So you want to know what is tooth growth means, you can give it in your help. It will show you what is the tooth growth. So in the tooth growth, response is the length of, see the values, see the things. So in the tooth growth, we are having length, supplement type is given and dose is given. Okay, so that's why I have taken it for the two-way ANOVA. Now, ANOVA of length we have to measure, right? We have to analyze. So length is the dependent or it is a response. It based on the supplement type along with the dose. So tooth length is depends upon supplement type and dose. So supplement type and dose will be the independent variable and data equal to tooth growth because we have taken the tooth growth. If we are if you are taking the summary, you will get the ANOVA result here. So based on the alpha and P, we can take the decision. Suppose we want to see the interaction plot, right? We want to see the interaction plot among the factor and the response. We can check this also. See here, already I said no, interaction dot plot of tooth growth. Why we have to give dollar means because that particular thing only will we want to extract means we can use the dollar here. So from the tooth growth data, I want dose. From the tooth growth data, I want supplement. And to tooth growth data, we want the length means we can take the needed thing by using the dollar symbol. So this is our a plot. So this plot will tell you the interaction among the factors. So the line represents, see here the dots represents, and the line tooth growth means supplements, and the length and the dose. So this is the interaction among the three things. So like this we can use it. Next thing is, if we are having some Excel sheet, we want to do it means, we first what we have to do means, see, already I have tested one thing and I have taken. Just I will explain this. You can apply the same thing to your research problem or whatever you want. First thing, we have to save our Excel file as a CSV file in our working directory. The first thing is we have to save our existing. I'm not going to export and showing everything. Just I'm explaining how to change your working directory and how to select it. So already I have taken one data as some diet. So diet data I'm having. So in that we have to analyze the variance of weight loss with diet type and gender. This is already existing in the data. I'm having the data in the Excel. So I have to save the data as a CSV. As all we know that how to save the CSV, but we have to save it in our working directory. So how to change the working directory? See, once again, get WD if you are giving, then if you are executing it, it will show you the working directory. So desktop is my working directory now. Now suppose I want to change my working directory means you can use the shortcut Control Shift H. Together if you are giving Control Shift H, then it will ask where to set the working directory. So like that also you can select the working directory, or else here under the files, settings is here now. So you just click that. So here through this also you can set your working directory. Why I'm saying means you have to save your Excel file in your working directory. So already I saved it and I have executed that. So diet is my file name. Whatever file name you are giving, the same thing only here also you have to give. So diet equal to, we have to first read the CSV. So read.csv within the parenthesis, just within a quote, you define your file name. Then ANOVA, we want the two-way ANOVA, no? So from the diet file, so both are diet means you may get confused. So here diet one we can take. So diet one. So in the diet one, I want the weight loss. So weight loss is my dependent factor. Weight loss depends on gender and the diet type. That all we know that. So this is the response and these two are the factors. So why we are using the dollar means because already the data are in Excel, I mean in CSV. So we are extracting the required thing alone. That's why we are using the dollar here. And if you are giving the summary, then we will get the ANOVA result here. Then by using the p-value and alpha value, we can take the statistical decision. So the first factor in diet type, a p value is less than alpha. So we are rejecting the null hypothesis here. But with the gender, it is greater than alpha. So we are accepting the second hypothesis. So rejecting first hypothesis and we accepted the null hypothesis. So like that, we can give the conclusion. So one more computational problem I gave here. And one more thing I gave to test the level of significance and 0.01 means here you have to include confidence level. So alpha is 1% means then confidence level should be 99%, right? So confidence level equals 0.99. You have to include if you want to measure with the particular thing. Additional thing, one more additional point you have to add. Yes. Thank you, professors. Thank you for your patience listening and for this opportunity.
Thank you, ma'am. Thank you for a wonderful presentation.
Thank you, ma'am.
Now I wish to call Dr. Jayanti, Head, Department of Computer Science, to present the vote of thanks.
Good afternoon. Good afternoon to one and all. At the outset, I would like to thank our Managing Trustee, sir. My sincere thanks to our Principal, sir, Vice Principal, sir, and our college DPT Coordinator, Dhanapal, sir. Our Chief Guest, Dr. Anita. She has given a clear view on the concepts of R programming, R Studio, testing of hypothesis t-test, chi-square test, ANOVA. Ma'am, now we have clear knowledge on these concepts. Thank you, ma'am. Thank you. Once again, I express my sincere thanks to you, ma'am. Thank you. Thanks a lot. My sincere thanks to our directors, Dr. Christopher, sir, Dr. Yamini, ma'am, and HODs Suganya, madam, Grace Padma, ma'am, and Mageshwari, ma'am. And I would like to express my thanks, Vinith, sir, for his support. My heartfelt thanks to Dr. Padma Priya, HOD BCA, and her team for their extraordinary support, cooperation in successfully completing this session. Thanks a lot, madam. I express my thanks to Vivek, sir, and Palisamy, sir. Thank you, sir. Thanks for attending. My sincere thanks to all the directors and the HODs, and a special thanks to all our department faculty members. Once again, I thank you one and all. Thank you. Thank you, ma'am.
Thank you, ma'am. Thank you for your support and your constant support, because Padma Priya ma'am is constantly following me. Thank you, Padma Priya ma'am, for this opportunity. And I thank everybody, every professors and the management, organizing committee members and the organizing secretaries, and above all the head of the departments, and to everyone. Hope today's session will be helpful for your future research works, and you can implement for this one to your research works. Thank you, ma'am. Thank you, one and all, ma'am.
Thank you, ma'am. Thank you.
Shall I leave, ma'am?
Yes, ma'am. Thank you.
Yes, ma'am. Yes, ma'am. Faculty members, kindly fill the feedback form, please.